In number 5, we have a particle traveling backward and forward along one dimension, and it has a velocity right here, this following function. So we know that the particle's initial position was 2 units. So first let's think about what that means. So the letter that we usually use for position functions is s. So if the initial position was 2 units, that means that at the start, meaning at t equals 0, so s of 0 is equal to 2. So whatever the s, the position function is, if we plug in 0 to it, we should get 2. So it started at x equals 2, essentially. We want to know what was the position when it was traveling the fastest between 1 and 4 seconds. So that's kind of a two-part question. First of all, we need to know the s function in order to answer that. But we need to also know when it was traveling the fastest. In other words, we want when was the velocity the biggest between 1 and 4 seconds. So we need to take the derivative of velocity and set it equal to 0 to find the maximum of velocity. And then we're going to have to do the antiderivative of v later in order to get our position function. So first let's do v prime of t. And we know we're setting that equal to 0 because we want to find a maximum velocity. So if we do the derivative of velocity, we'll get 3t squared minus 18t plus 24. Since that's equal to 0, it would be in our best interest to factor out a 3 here so that our factorization becomes as easy as possible. We'd get t squared minus 6t plus 8. And this, excuse me, this factors nicely into t minus 4, t minus 2. So this is our v prime. We're setting that equal to 0. So we get two values for t, 2 and 4, where our velocity, the derivative of it is equal to 0, meaning we have either a min or a max. So to figure out which is which, let's make a number line. The two numbers that we're putting on it are 2 and 4. And we simply need to figure out whether the velocity is increasing or decreasing along those lines, and the derivative being positive or negative will tell us that. So you can do some quick plugging in of numbers here to test this, but it ends up looking like this. So our derivative is positive less than 2 and greater than 4, and it's negative in between 2 and 4. So that means it's the v of t function is increasing here, decreasing here, increasing here. So it would have a maximum where it goes from increasing to decreasing, so that's right here. We have a max at t equals 2, and that's in between 1 and 4 seconds. So it was traveling the fastest, and keep in mind, it didn't ask us to actually figure out what that velocity is. It just said when it was traveling the fastest. So at time equals 2 seconds, it was traveling the fastest. Its velocity had a maximum. So we want to know what was the position at that time. So essentially, now we're asked, what is s of 2? And that's the answer to the question, because we know that the t equals 2 is when our velocity was at a max. So to answer this, we need s. And to get s, we have to take the antiderivative of this function here. So when we take the antiderivative, we're going to be using our antiderivative power rule. And remember, that's the exact opposite of how you do the regular derivative power rule. So when you do a derivative, you bring the power down and lower the power by 1. So you do the exact opposite here. You increase the power by 1 and then divide by that new power. So t to the third would become t to the fourth divided by 4. Remember, constants stay there just like they do with regular derivatives. So we'd still have minus 9, but then we'd have t cubed over 3. So this would become negative 3 t cubed, because the divided by 3 cancels out with the 9. Same thing here. We'd still have the 24, but then we'd have t squared over 2. So that would cancel to give us 12 t squared. The antiderivative of a constant, we would just put a t on there, minus 12t. And then we have a constant of integration that's always possibly there because there could have been a constant here that when you took the derivative to get velocity, it would have disappeared. So there always could be a constant at the end. We can figure out that constant. Keep in mind, we can't answer the question right now because if we plugged in 2 here, we don't get an answer because we don't know what c is. But that's where this helps us out. We know that if we plug in 0 for t, we have to get 2. Well, that actually makes this really simple because if we plug in 0 for t, all of these terms are 0 because t is 0. So therefore, c has to be 2 because we have to result with 2. So we know that this c is 2 from this right here. So now we're ready to answer the question by plugging in 2. So let's plug in 2 for t. So 2 to the 4th is 16, and 16 divided by 4 is 4. 2 cubed is 8, and 8 times 3 is 24, so we get minus 24. 2 squared is 4, and 4 times 12 is 48, so we add 48. 2 times 12 is 24, so we subtract 24, and then we add 2. So negative 24 and negative 24 is negative 48, and that cancels out here. So this all cancels out. We get 4 plus 2, which is 6. So the particle's position was 6 at time 2, which was when it was traveling the fastest.
The Teaching Center, UF's Learning Resource Center.